Hello students, differentiation of vector functions. First, we start with rectilinear motion. If a particle moves in a straight line, it's said that it moves in a linear motion. Linear motion. 2. Position of the particle. When the particle is at position A, here, on the straight line, then x equals 5c. What's the distance between O and A? It is 5 units in direction of C. 1, 2, 3, 4, 5 units in direction of the unit vector C, where C is a unit vector in the direction of OA. Actually, it is in the positive direction of the motion. But if the particle is at position B on the straight line, then x equals negative 3c. B lies on the negative part of the line. So x equals 1, 2, 3. It is equal negative 3c. Displacement. The displacement S, it is a vector of a particle, is known as the change of its position. Here we have a particle, its position, it changed from A to A dash. So the difference between x dash and x naught, it is the initial position, and x dash is the terminal position. So delta x, it is the displacement. It is the difference between x dash and x naught. So displacement S equals delta x, and delta x equals x dash minus x naught. First, delta x is positive since the particle's final position A dash is on the right of the particle's initial position. A dash, it is after A. So the difference between A dash and A dash minus A, it is positive. Second, if the final position of the particle is on the left of the initial position of the particle, then delta x will be negative. For velocity, if S equals delta x is the displacement of the particle during a period time delta t, then the average velocity vector VA is equal to the quotient of the displacement over the time. It's very, very important. So VA, it is the average velocity vector, equals delta x over delta t. Delta x is the change of the position. It is xt plus delta t minus xt over delta t. The instant velocity vector v at any moment t is defined by the relation v equals limit the average velocity. V equals limit the average velocity delta x over delta t when delta t tends to 0. It is equal to limit x of t plus delta t minus xt over delta t as delta t tends to 0. From the definition of the derivative, we can deduce that v equals dx by dt. It is the slope of the tangent of the curve of the position time. B. The velocity vector is equal to the rate of change of the displacement with respect to the time. So V equals ds by dt. It is the slope of the tangent to the displacement time graph. C. The magnitude of the velocity vector is calculated in the unit meter per second in the international system of units. The symbol V can be used to express the algebraic measure of the velocity vector V. 5. We have another definition. It is the speed. The speed is the standard quantity expressing the magnitude of the velocity vector. It means the speed equals norm of V. It is equal norm of dx by dt equals the norm of ds by dt. B. If V is the algebraic measure of the velocity vector and x is the algebraic measure of the position. So the velocity equals absolute of V, it's equal dx by dt equals ds absolute of ds by dt. Once more, the velocity equals absolute of V. It means there is no positive or negative. The velocity is the magnitude of V, which equal dx by dt absolute of dx by dt equals absolute value of ds by dt. Example: a stone is projected vertically upwards and its height x after t seconds from the projection is given by the relation x equals 4090 minus 4.9 t square. Here we have x is a function of t. So x equals 4090 minus 4.9 t square, where x is in meter. So this is the given. What is the required? Find the maximum height the body can be reached. B. Find the algebraic measure of the velocity vector when the stone is 78.4 meters high. Then find its velocity. C. Graph. Graph is very important, and we will discuss the graph of the position time graph and the velocity time graph, and we will use it to analyze the motion. Solution: in the coordinate system of the motion in a straight line, consider x measures the height or the position at the projection point. V is positive in case of moving upwards. So this is the deal. V is positive in case of moving upwards. Xt equals 4090 minus 4.9 t square. It is a given. So to find the maximum height can be reached, first we will calculate the velocity. As in the maximum height, the projected body can be reached, the velocity equals 0. So we want to calculate the velocity. Vt equals dx by dt, which equal 49 minus 9.8t. What's the derivative of 49t? It is 49 minus 2 multiply 4.9, it's equal 9.8t. We subtract 1 from 2. So Vt, V as a function of t, equals 49 minus 9.8t. At maximum height, V equals 0. So the stone reaches the maximum height when V equals 0. 49 minus 9.8 equals 0. It means 49 equals 9.8t. Then t equals 5 seconds by dividing 49 over 9.8. So the maximum height equals x of 5. As I said before, x is a function of t. So after 5 seconds, the body will reach to the maximum height, and to calculate the maximum height, we substitute t equal 5. So x5, it's the maximum height, and it's equal 49 multiply 5 minus 4.9 times 5 power 2, which equal 122.5 meters. So this is the maximum height. B, what is the required B? We'll back to the example again. Uh, the required is to find the algebraic measure of the velocity vector when the stone is at 78.4 meters high. So B, the stone is 78.4 meters high when x equals 78.4. From this, we will calculate the time. So 49t minus 4.9t square equals 78.4. As x always equal at any time, at any instant, x of t equals 49t minus 4.9t square. So we substitute xt equals 78.4. So we have the equation, second degree equation, quadratic equation, 49t minus 4.9t square equals 78.4. And to solve it, we change the sign and we arrange it. It will be 4.9t square minus 49t plus 78.4 equals 0. We simplify it by dividing both sides by 4.9. So we have the equation t square minus t minus 10t plus 16 equals 0. And we will factorize it. T square it is equal t multiply t, and 16 it is equal 2 multiply 8 with the sign of the middle term. We have 2 by negative sign and the negative 8. So t minus 2 equals 0. It means t equal 2. What does that mean? It means that the body, it will be at the height 78.4 after 2 seconds. Second, V2 equals 49 minus 9.8 multiply 2. It means the velocity at this moment equals 29.4 meters per second. Second, t minus 8 equals 0. Then t equal 8. So the body will be at the same height again when x equals 78.4 after 8 seconds. So what is the velocity at this moment? We calculate it. V8 equals 49 minus 9.8 multiply 8 equals negative 29.4 meters per second. It means the stone is 78.4 meters once ascending after 2 seconds and once descending after 8 seconds. You can imagine it. The stone projected upwards and it will be back again and descending. And we'll discuss it through the curves. The algebraic measure of the velocity vector is either 29.4 or negative 29.4. Then the velocity of the stone in the two cases equals absolute of positive or negative 29.4, which equal 29.4 meters per second. Here we'll discuss the journey of the stone on this graph. From the position time graph, we find that we have the position by the equation x equals 49t minus 4.9t squared. When you draw it, starting from 0 till 10, we have this curve and we can discuss it. After 5 seconds, the stone will be at this height. Okay, after 2 seconds, the stone will be at height 78.4. When the stone reaches the maximum height, it will stop at instantly stop, and it back again to the point, actually to the height 78.4. After 10 seconds, it will be back to the point of projection. Of course, the stone moves in a straight line like this. Consider that it moves through the straight line like this, not in this curve. This curve only to represent the motion. So the stone reaches the maximum height 122.5 here meters when t equal 5. When t equal 5, the maximum height will be at 122.5. The stone gets back to the projection point once again when t equals 10 seconds here. The point B is 10 and 0 here. The ascending stage took 5 seconds and the descending stage took another 5 seconds. So the total time will be 10 seconds till the body reaches its position again, its initial position again. The stone was at 78.4 meters high when t equals 2 seconds here and t equals 8 seconds. Here it is the height of the stone. Again, back again, to explain this again, after 2 seconds, this is the axis of time and this is the axis of position. After 2 seconds, the stone will be at height 78.4. And after 8 seconds, the stone will be at the position or at height 78.4 meters again. Here, from the velocity time graph, we find that the starting velocity of the stone was 49 meters. Here, when t equals 0, the velocity was 49 meters per second. And it gets to decrease during the time. And it's clear from the straight line. After 1 second, its velocity will be 39. After 2 seconds, its velocity will be 29.4. After 5 seconds, it reaches to the maximum height, and it will change its direction again. Notice that the velocity in this part is positive, and in this part, after 5 seconds, is negative. What that mean? It means the, that the stone changes its direction after 5 seconds. After 5 seconds, it is the top of the previous curve. Okay, we'll complete, and it is gets to decrease during the time interval 0 to 5. Until the stone got instant static when t equal 5. It will stop after 5 seconds to change its motion, to change its direction when the stone reaches its maximum height. Then its velocity increases in the opposite direction in the time interval 5 to 10. And it's clear here, from 5 to 10 seconds, the velocity will be negative. Under the time x, it turns back to the projection point when t equals 10 seconds. Here, when t equals 10 seconds, it back again to the projection point with velocity negative 49, but it is absolute equal 49. Again, at the same projection velocity, 49 meters per second. Number 2, the maximum height of the stone can be calculated by the velocity time graph in 2 methods. Here, the maximum height equals the area of triangle OAL. OAL. The area of this triangle under the curve of velocity, under the line segment LA, which represents the velocity. This area equals the maximum height, equals half OA multiply OL. Half OA multiply OL, as you know, that the area of triangle equals half the base multiply height, equals half multiply 5, from 0 to 5 is 5, multiply 49, it's equal 122.5 square meters. Or we can get the maximum height by calculating the integration This method will be discussed in details later. Finally, I hope you understand everything. I hope you understand this example, and we will continue using examples and questions in next lessons. Goodbye.